Hello, my name is Dave Hedeman. I'm the application specialist for the steel segment here at Tekla Inc. And today I'm going to show you how you can quickly model in a stair tower using Tekla structures. I've already gone ahead and created a new model using the U.S. Imperial environment and the steel detailing role. So a lot of the settings that you'll see me loading are going to be what would be included out of the box when you start with those settings. First thing I want to do is go ahead and change this grid. So I'm going to set up the grid for each of my levels and then also the dimensions of the interior of my stair tower. So very simply, I'll come in here and say that I want spacing at 4 feet, 12 feet 9, and 4 feet. So that's going to basically be my landing width, the spacing between my landings, and then the next landing width. For my Y dimensions, start at 0, 2 spaces at 4'3", and then my Z elevation, so 0, and then I'm going to do a level at every 15 feet. So 45, 60 feet, and 75 feet. So to help make things a little more easily identifiable, rather than using regular grid labels like 1, 2, 3, ABC, I'm actually going to give these grid lines some names. So I'm going to call the first grid the east wall, landing 1, landing 2, and the west wall. And then in the Y, I have my south wall, the center of the tower, and then my north wall. So I can go ahead and create views based off these grid lines. So now I have all the views I want to work in. The one I'll be spending most time in is this elevation on the center, because this is where I want to be inputting my actual towers. First thing I'm going to do is come in and set out a landing. So this is something that I would normally have done already. Basing off of my 11-inch width, 7-inch depth, average tread that I'm going for, I would have simply laid out some construction lines or just use a calculator to figure out where I wanted this to be. So now I'm going to go ahead and create a quick view so that I can make my landing framing. I've already calculated that I want the top of concrete to be at 6'11". So I'm just going to go ahead and create a basic view at that level. So I'm just going to put in a real simple bit of framing. I'm just going to put a channel for the header beam. I'm going to make this a C12. And also, 6'11" is my top of concrete, so I want to drop this down by 4 inches to allow for that concrete and deck to take up that 4 inches of spacing. Now obviously I could go in here and I could connect all this together. I can put some intermediate beams in there, or angle framing, but that's not really the focus of this particular video. I really want to stick to the miscellaneous tools. So if I were to go ahead and start framing in my stair, I'm going to go to the component catalog, and we have a whole section here called Stairs and Railings, where you'll find a lot of different components regarding handrail, posts, different types of stairs and steps, different handrail connections, ornamental pickets, and custom components. There's really a lot of good settings in here. I'm going to be using the Z-Pan stair today. This is S74. And the first thing I want to do is load a preset called Stair All. Now, what Stair All essentially does is it makes sure that this stair is going to be all shop welded together so that it can be dropped into place in the field. And I have some options here on the first picture tab before I put in the stair. I have drop downs at the bottom and at the top to indicate how I want this stair to be shaped. Say, do I want it to frame to a header beam? Do I want it to frame to a landing beam? Do I want a step to be created at my first nosing point, or is my first nosing point going to be top of concrete? So these are things that you should pick before you create the stair, because that's actually going to affect your picking order. You can see that the base stair, if I wanted to do the bottom and top of the stringers manually, my nosing points are located point 1, point 2. Those are the two places I pick. If I were to change this to where I want to land on a beam, you can see that my picking order has changed. It's now nosing, nosing, landing beam. If I do the same thing at the top, my picking order has changed again. nosing, nosing, landing beam, landing beam. You can see how they're numbered to make things a little bit easier to find. So I'm going to go back to where my finished floor is going to be my first nosing point picked. This means that I don't want a step to be created at the finished floor. I mean, that's where we're going to have concrete. And then I'm also going to set the option to frame to a beam at the top automatically. Now, you don't have to do this. You can always notch it manually. However, when you can, it's always a good idea to take advantage of the options that are available. So I'm going to set this stair to be 3 foot 6 inches wide. And I think we'll go with that for now. I can always adjust the settings after it's in. So I'm going to start off down here. Again, these are my nosing points that I've already laid out. So I'm going to turn on some of my snaps here. I'm going to come over 1 foot 5. And then off of this landing beam that I'm framing to, I'm going to come up my 4 inches for my concrete and deck. And then back 4 inches for my slab edge. Finally, I pick the beam as per the component. And middle mouse click to finish. So we can see that after a moment, Tekla's gone ahead and created a simple stair for us. With the out-of-the-box options, it's gone ahead and created brackets underneath. We can take a look at those options in a moment. We can also see that our treads have been equally spaced. Now, I did do the math first to make sure that I got some treads that would work for me. But Tekla will take the 2 points that I've picked and actually equally space those steps based on this dimension right here, saying that the maximum riser height is 7 inches and it won't go over that. So in this example, if I were to come in here and measure this quick, just picking nosing to nosing, you can see that this is a 6 15/16 rise and a exactly 11-inch run. So right about where I wanted it to be. Now, as far as some of the options available in this picture tab, now I could change the way the bottom of this stair is dimensioned, but we're going to be worrying about that a little bit later. So to start, here up at the top, I can adjust some dimensions as far as how far past that nosing point the end of my stringer is. So if I wanted this, let's see if I measure to the center of my channel, it's 5.5 inches. So if I make this, say, 6 inches, after adjusting that dimension, I can see now that the end of the stringer is going to adjust to that 6-inch dimension. If I want my top of stringer to adjust above that top step a little bit, say I wanted to have an inch gap to the top of that plate, I could go ahead and put that dimension in here. Now I do have a 1/4-inch plate, so I am going to account for that. So I'm going to actually raise the stringer itself 3/4 of an inch above. And I can also adjust some of the dimensions for this plate. So if I wanted to have a little bit of a setback so I could get a good clean fillet weld on there, maybe I want to set that back by 1/4 of an inch. So as you can see, the Tekla dialog boxes are very user-friendly in the sense that I just fill out dimensions to get the shape of the stair and the stringer that I want. Everything's pretty clearly labeled from nosing points and from edges of material. So it's just a matter of filling in the dimensions and the sizes that you want. Another example is if I wanted to have an 1/8 inch gap to provide a little bit of clearance on the back of this, I'll just follow this dimension here. And now I have my 1/8 inch gap. Now as far as some of the other options, if I come here to the Stair Setup tab, this is where I can change things like the position of the stair and the type of brackets. First, looking at the brackets, the out-of-the-box standard Stair All option is to provide that angle bracket underneath the tread on either side. So you can see here that that is the default, but I could also choose to have a bracket on the underside and on the back of the pan, or a bent plate bracket underneath the pan, or no bracket at all because the pans are just going to be welded to the stringers. This tends to be the most common option I see, so I'm going to go ahead and load that up to have no brackets created. After I modify it, I'll remove those. We have options for whether or not we actually want to create a top step or a bottom step. Perhaps this is going to be created by the decking or some other type of slab edge. I'm going to leave that on, and then the same thing for the bottom step depending on what you're framing to. Now if I move this over so that we can see the location of this stair, we can see that it's actually been centered on that grid line because that's the elevation I'm working on, is the center line of my stair tower. So what I really want to do is offset this from center, and we have some options here. So position in plane, I can either offset it to the left, and this is looking from the bottom of the stair upwards. So I can offset to the left, I can offset to the right, and then I can also add an additional distance. So if I wanted to offset to the right plus, say, 6 inches, I could do so. If I wanted to make it 4 inches. So using these types of settings, I actually like doing an offset to one side because that means I can use the same settings in that grid center working all the way up the stair, and they'll be offset to the right each time, which means that I don't have to go in there and manually change them later. Now if I go to the Z-Pan tab, here I have a lot of different options about how my pans are shaped. So if I want to control the top of the pan for the nosing, if I wanted to provide something like a sanitary cove, if I wanted to change how the pan meets the nosing underneath, there's a lot of different options in here. Again, it's very user-friendly in the sense that I just follow the picture. What I see in the picture is what I'm going to get in the model space. So if I want to change something like this top pan, right now the top pan is coming back 11 inches. Well, obviously I don't need that much. I'm only going to have it match the end of the stringer. So I'm going to change this dimension here for my nosing to the end of my top pan to 6 inches. Make sure my stair is highlighted. And now my pan has gotten shorter. And then over here I can come down to the bottom and I can control this bottom pan. Again, I'm not going to worry about the base detail just yet. There's a separate component I can do for that. So let's go ahead and measure this. It should be matching that 6 and 15/16, and it is. So I can come in here and say from the nosing down to the bottom of this pan is 6 and 15/16. It's just a matter of, again, filling in the dimensions for what I want. We do have some options for how the pans are shaped. So if you want the pan to be bent out, it can be bent out. If I want it to be bent backwards, I can just put in a negative number and it will bend it under. Remember, this is going to be the nosing to the end of the pan. So I think that's pretty good for now for what I want for this stair. So I'm going to go ahead and say apply because I've now changed the offset to the right, I've changed the dimensional properties, I've changed my pan type, and now I want to go ahead and create my upper level stair. So I do need to change a few things before I go ahead and insert this. Because I want it to automatically notch around the bottom, I am going to have to change on my picture tab that instead of it just being an open-ended stair, I want it to actually bear on a landing beam. As far as the top side goes, I am going to, as I said, do that stuff manually. So I'm going to remove this option and just have it dogleg out from that top nosing point. I think that should be it for now. We'll see what we get. So I'm going to go ahead and say apply. And I'm going to reactivate my stair. So I'm going to start from this nosing point. I already know that my tread height is 6 and 15/16. I'll come up here to the top and I'm just going to offset 6 inches. I do have to pick the landing beam that I'm framing to, and then I can middle mouse click to finish. So as we can see over here in my 3D view, it has gone ahead and notched itself around that beam. I can adjust the same dimensional properties that I did for the lower stair. Let's go ahead and do that real quick. I'm going to go ahead and change this from the nosing point out to 6 inches, just like I did for the top. And I'm going to set that 1/8 inch clearance and the 1/4 inch dimension for the weld to the plate, just like I did for the top of the stair that's coming up from ground level. So I'll modify that stair, and pretty quickly you can see how it's automatically gone and adjusted itself. So at the top, a few options I want to change. This is going to be framing to a channel at some point. We can either take care of that now, or perhaps I'll keep it simple. I'll go ahead and set this to 8 inches for now. And notice I'm doing this for each stringer. When you have it set up like this where it's open-ended, not automatically framing to a beam, you can set the stringer lengths independently. So you could actually have one of the stringers on one side closing out part of the landing framing. We actually see that quite a bit. And then because I have no plate, I'm going to go ahead and set that to a full inch to the top of that stringer. hit modify, and you can see it's gone ahead and adjusted itself. Now I'm going to have to adjust this bottom pan because it's using the same dimensions that I was using at the bottom of the stair for the lower run. So I'm going to go ahead to the Z-pan tab, and we've got an additional 4 inches being added to this. So instead of 6 and 15/16, I'm going to go ahead and say 10 and 15/16. That should get me pretty close. And then I want this to project, instead of going and curving back, I want this pan to project out. So I'm going to go ahead and change that dimension to match the 6 inches that I have from nosing out to the end of the stringer. So we should be able to see here in the 3D view how my pan is now going out and landing on top of that beam. It's automatically notched out for me, and the end of the stringer is going to match what I had for the lower stair. So pretty quickly I've been able to knock out the major dimensions for these 2 stairs. So as far as adding some finishing details, if I go to the bottom here, I'm going to use another component that's in the stair and railing section of the component catalog. I'm going to use one called 1043 Stair Base Detail. And what Stair Base Detail is going to do is going to add a little clip. It's going to square off the end of the stringer for me. And then I can obviously control which side that clip is going to be on, and then some other dimensional properties that you see here. Just in the interest of saving time, I'm going to load up this out-of-the-box setting called Base Condition Left. I do have a slightly different height for my tread, so I'm going to go 6 and 15/16. And then this gets applied to individual stringers. So I'm going to switch to the Objects in Components button so I can simply click on the stringer and then my nosing point. And I'm going to go ahead and load Base Condition Right. This switches the angle to the other side, again setting 6 and 15/16, and then applying that to the right side stringer. So we can see how, let me go ahead and rotate this under. It's gone ahead and added some little angle brackets, and then of course we could put any type of anchors in there that we wanted to, whether it be a hooked anchor of some kind, which would be rare, or maybe an expansion anchor, an epoxy anchor. We have components that can do that kind of thing as well. So I'm going to go ahead and create a quick landing beam up here at 15 feet, and then we'll start putting in some railing on these stairs. Now for the top of this, I said that I wanted to manually control how I was going to notch around the landing. I could cut this manually, I could use something like a shear tab or even a clip angle. Any of our system components would work for these individual stringer sections. But we do have something specific for a drop-in stair. It's a custom component called Stringer Base Connection. As you can see, we have one here that creates a single plate and one that creates 2 plates. For this instance, I am going to only require a single plate. And there are some dimensional properties I can change about this. I'm going to go ahead and just leave them at the default and basically frame from the landing beam to the stringer on one side, landing beam to the stringer on the other side. I can see how it's coming past a little bit further than I'd like, so I'm going to change this to 1 inch. And that should be a little bit better. There we go. So very quickly I've been able to complete the upper and lower stair sections. These would actually be ready to go ahead and create some shop drawings, fabrication information such as CNC files. All of that stuff is ready to create here with just that little bit of work. So let's go ahead and start putting some railing in on this first run. If I go back to my component catalog under the stairs and railing section, we have a lot of different handrail components, some that can put in just posts, some that can put in the whole railing at once. I'm going to show you how we can put it in section by section. So we're going to start here with the posts or the stanchions component. I'm going to use this S76. So I'm going to go ahead and use a preset that's out of the box called Posts Up Stringer. Essentially this is going to be welded posts to the top of the stringer, so not bolted or anything like that, although we do have some options that could do so. And you can see here from the picture tab how I can insert this component. So my first point, starting point, ending point, and then which objects I'm going to be bearing on. So I'm going to come in here, I'm going to start at the bottom of this stringer, I'm going to go to the end of the plate, and then pick the 2 parts that these posts are going to be bearing on and middle mouse click to finish. So I get, as you can see very quickly, some simple pipe posts. Now, with this tool, with the stanchions tool, I can go ahead and create any type of post that I want. If it's available in the Tekla Structures catalog, I can use it here. So if I, just as an example, if I wanted to put in some HSS pipe posts, I could do some 2x2 by quarter or something like that. Go ahead and make sure that's set for all of the posts. I can modify, so now I've got square posts in their place. If I wanted to do flat bar, I could do plate quarter by 2.5 because these tend to be pretty popular. They're nice and cheap and easy to make. I'm going to have to change the rotation of the plate so that they're facing the right direction. But I could go ahead and make some flat bar posts if I like. So you have a lot of different options here for how these would come together. And this is one of those benefits about the ability to really fine-tune what your railing is going to do. So I have a preset that I'm going to use. This one's called, this is a personal preset called HSS Post Substringer. Basically, it's just going to be the HSS post with a set height of 3'6", and then 2 inches to my starting and ending points for where these posts are going to be located. Okay, so that's really what you want to do is when you customize and you set up something like this, you want to come up to this top section and save it away so that you can reload it at a later date to make your modeling a lot faster. Especially if this type of post maybe is a standard for you, saving this away means I don't have to go ahead and set this up again later. So I'll say apply, and I'm going to go ahead and use those same settings for the upper stair. Rotate my 3D view here so I can get a better view. So here's where I want them to start, and up here is where I want them to end, and then I want to apply them to the 2 stringer sections. Finish with a middle mouse click. So as you can see, very quickly I've been able to get my posts equally spaced out. The maximum spacing on that component, I believe, is 4'6" between the posts. So very easy to use. And then I could go ahead and also manually create some posts just by using the column or the beam tool. So if I had a very specific location where I wanted one to be, I have that option to use a mix of automatic and manual tools. So now I'm going to go ahead and connect this lower run using our handrail S77. And I'm just going to use one of our out-of-the-box preloaded settings here that you would get with the US Imperial environment. This one's called Rails No Returns. This isn't what I actually want to use, but I just want to show you some of the different options available. So I'll come in here and I'll pick the post that I want to apply this to, and you can see how I get a simple run of round pipe. So we can do round pipe. Again, we've got a lot of presets in here. So I could load something like, I've got a picket rails, if I wanted to do some picket rails. I've got a glass panel option if I wanted to do that. So I can put in some glass panels. I could put in some industrial angle if I wanted to do that. So we have a lot of different options in here. Again, you would just customize this the way you like, save them away, and then you could reapply it very quickly later. I have one specifically for that purpose. I'm going to call in my HSS picket rails. So basically this is going to put in square pipe for the rail and equally spaced square pickets. So I'm going to load that up, hit modify, and now I've got my square pickets and my square rail. To finish off the top and the bottom, there's a lot of different options for whether we would want this rail to extend or whether we want it to stop at the post. I'm going to use this component called railing miter, which will very quickly allow me to just put a quick miter cut between those two parts to put them together as a single unit. So I'm going to go ahead and use those same settings to apply to the upper stair. Just picking on those posts in succession. And then again use railing miter to just finish off and put a nice miter cut between the post and the rail. So if I wanted to do something now like a grab rail, I would use this same S77 component. We have a preset here for grab rail up left side and grab rail up right side. So I'm going to load up grab rail left side. I'm going to go to the middle rails tab because I do want to have a slightly different diameter. I'm going to make an 1.25" pipe. And just apply that again to the lower section. So here we can see that it creates the rail, it creates some simple brackets, and I also have some options about how far it extends down past this bottom post. If I wanted, I could come in here and say that I wanted to extend maybe 6 inches, or that I wanted to extend maybe even a foot, and it will adjust that rail accordingly. I do want to show you though how you can make some of these bends and finishing parts custom using some manual tools like Polybeam. So I'm going to leave that as is for now. So I will go ahead and use these same settings on the upper rail. So I'm going to single click to activate the command, and then just pick those upper posts in order, and finish with a middle mouse click to create the rail at the top. So if I wanted to connect these two together, we do have components such as the railing beam to beam that you can see would make a return on that. I'm a little more particular about the shape of the return, so I like to create those myself. So what I'll do is I'm going to lay out a poly beam here to return around. Then I can also break it in the middle for where it's going to be two separate pieces, one shop welded to the lower rail, one shop welded to the upper rail. So I can use some construction lines. There's many ways I could do this, but I'm just going to use some construction lines to very quickly lay out where I want this to go. So I'll extend that out 3 inches. I'll activate the Polybeam tool, and what's neat about the Polybeam tool, if you haven't done so already, I can come in here and select one of these existing pipes if I'm not sure, if I just want to very quickly get its properties. Use the Get button, and it will fill in the pipe 1 1/4 size for me. Well, I can just go ahead and start creating this Polybeam. Actually, throw in one more construction line to make my life a little bit easier. Okay. So I'll start at the end, come down to the intersection of these two construction lines, come off 3 inches, and back again, little mouse click to finish. So if you haven't done this before with a Polybeam, you can also create some radiuses at bend points if you like. So maybe if I want to put a 2-inch radius in there or something like that, I can do so. Just so I have a nice smooth arc for your hand to follow around the corner. And then again, if I wanted to put a breakpoint in here, we can use the split command so that I can break this at the midpoint so that I know that the lower section can be shop attached to the lower and the upper section can be shop attached to the upper. To ensure that, I'll just go ahead and create a quick weld, welding one to the next. And finally, I will check and make sure that these are welded together properly. So that's an assembly, good. And the upper part is an assembly, also good. Okay. I can also do the same thing or a similar type of thing down here for the return. Everybody likes to do this a little bit differently, so I'll start here. I'll come back 6 inches, come down maybe a foot, and then over 3 inches. Something like that. I mean, everybody does a little bit differently. If this is a wall, you might want to just end it, put a cap on it. Sometimes you might want it to return back to the post again. But using the Polybeam tools, you can go ahead and shape that really however you like. I mean, that's one of the great things about a Polybeam. Depending on what kind of ending you have down here, you have some components like this railing end cap that you could apply. You could just leave it open. You can maybe put a circular plate on there. Really, what any of the options that you would like to have, you can do that here. Just for simplicity's sake, I'm just going to go ahead and weld this in place again, and then one more time check to make sure that everything is welded together properly as an assembly, and that looks good. You always want to make sure that when you're dealing with rail in Tekla, that the top rail is your main part, showing there in orange. You'll have better results on your drawings, so just one thing to check for. One nice thing is that I'm going to be able to reuse a lot of the stuff I have now. Because the spacings between my floors are equal at 15 feet, my upper stair and my landing locations can be reused. It's really just this lower stair that'll have to be recreated to match going from steel to steel rather than concrete to steel. So I'm just going to go ahead and get this copied up to roughly get started. Let me open up my elevation view again. I'll just do a simple copy to copy those parts up to the next floor. So again, a lot of this upper framing is going to be fine. My landing location is going to be fine. because I know that this stair and the treads have the correct rise and run that I'm looking for. So it's really just this middle stair that's going to need to be rebuilt for steel to steel framing. This particular stair, the easiest way to correct it would really be just to delete it and put a fresh one in, especially at this stage, because I'm putting in a different type here. In order to maintain the same rise and run, I'm going to have a dog leg at the top and bottom, rather than it just bearing on the supporting steel and then coming down here, and because I'm not framing the concrete at the bottom. So because I'm changing the type of stair, the configuration of the stair, essentially right here on the picture tab, I'm going to be changing so that I'm not landing on a beam. That changes the picking order, so it's just easier for me to delete and recreate it with the correct settings. Also, when I delete the stair, the handrail for this section is going to disappear, but I already have those settings, so it'll be pretty quick for me to go ahead and recreate that. So I'm going to go ahead and adjust some properties before I delete it, now that I got this dialog box open. So I'm going to go ahead and change that again to be extending out. I don't know what these dimensions are going to be just yet. I do already have this stair laid out, but I want to show you, just in case you don't have it laid out yet, kind of a poor man's way to check and adjust as required to get the proper rise and run for your treads. So I'm going to leave that as a foot for now. At the bottom here, I'm going to be starting from the same nosing point, and I'm going to go ahead and set this so that it will create a tread at that location. And I believe from the nosing out we went 8 inches, so I'm going to go ahead and say 8 inches. And then because I'm going to be kicking up, I'm going to adjust this dimension here. I want the top of my stringer to be 1 inch above the nosing, so I'm going to set this to be a -1 inch. You can see from the dimension properties here. So that should be pretty good to get me started with this anyway. So I'll go ahead and say apply to make sure I get those for the next stair, and then I'll delete out the one I have. Again, this upper framing is fine the way it is. There's no need to rebuild that. So I'll go back to my component catalog, single click to reactivate S74, and I will single click at my lower nosing and then move up. And I know that my my top of concrete is 4 inches above this header beam, so I'm just going to come up 4 inches. I could come back a little bit. Let's just place it at 4 inches for now, and then I'll middle mouse click to finish. So now that I have this stair roughed in, now I want to definitely adjust some of its dimensional properties so I can get the right rise and run for these treads. So let me go ahead and measure these real quick. And like I said, this is something that you could have laid out beforehand, that I would already know where this was supposed to go. But I wanted to show you just kind of a poor or a lazy man's way to just kind of do this on the fly. So what I did is I threw in this stair, just picking some existing like top of concrete, existing nosing, and I'm getting this 1'0" and a quarter. So what I can do now is I basically either choose, I want to move the top or the bottom, maybe I want to move both. For this particular example, I'm going to leave the bottom where it's at. I am going to adjust that bottom pan so that it comes out and bears on this beam, but I want to get the spacing laid out properly first. So I'm not going to adjust the bottom, but I am going to adjust the top for how this frames into the landing steel. So what I can do is I can come in here and just start moving this handle back until I get the proper rise and run that I want. Now, what's going to make this easy is that I already know that from a nosing point to any particular nosing point is going to give me the right tread length of 11 inches. So what I want to do is come back until I hit the right nosing point. So really, to do that, when you highlight your stair, you want to make sure you highlight it as a component, so that you can grab that handle, that insertion handle, and then you can just use a regular move command to adjust it. So if I go ahead and say, I'm going to use move linear, so I can just pick, maybe I want to try this one first. This is going to bring me back in the X 4 inches. So I'll move that stair back a hair, and then I'll just double check my dimensions. Again, this is just kind of the lazy man way to do this if you don't feel like breaking out your calculators. So I can see them a little bit closer. I was at 1 1/4, now I'm at 11 15/16. Let's move it back one more tread. That should do it for me. So I'll use my move special linear again. And I'll literally come back one tread width, 11 inches. If it's not coming out to exactly 11, that's when the move linear really comes in handy. In this instance, I've got it laid out to be perfectly 11 inches, so I could have just typed it in. So I'll go ahead and hit move again, pull that stair back, and let's go ahead and redraw my view and then redimension. I believe that's the correct point that I'm looking for. So if I measure these again, yep, so there's my 11-inch width and my 6 15/16 height. So like I said, all I had to do was grab that handle and just pull it back until I got to the right dimensional property. So you can adjust these on the fly like that pretty easily. So really all I need to do beyond that is I need to extend out all of these parts to bear on the correct steel. So let me go ahead and measure this. So from there to the middle of that channel, it's currently 1 foot 4.5. So let me just say roughly 1 foot 5. So I'll come up here and change my stringer extension to 1 foot 5. And I don't want to forget that top pan. I'll also make it 1 foot 5. So now that's extending out properly. And then I'll finish this off in a moment, but first I want to come down here and adjust this bottom pan. So this is still being dimensioned out as if it were coming down to a concrete floor. So really all I need to do is set its depth, make sure it only comes down about 4 inches for this, the concrete decking. And then I want it to turn out, this was at 8 inches, so I'll just set the same thing. I'll set it to 8 inches. And now my pan's going to kick out and rest on top of that landing beam. So again, all very visual, very dimension-based. I just come through and adjust the dimensional properties that I want until I get the actual stair layout that I'm looking for. Now, if I like, I can go ahead and start finishing off the end of these stringers before I copy it up the rest of the way and put my handrail on it. So I'm going to use this stringer base connection again. Just going to use the same settings that I used before on the lower section. So remember, I want to apply this to the individual stringer pieces. So I'll simply pick on the beam and then the stringer that it's affecting. And I'll reuse these up here. I may have to adjust the dimensions on them. Let's go ahead and just place what we have. So let me measure. I want to make sure that my stair ends match here. So right now I'm looking at a 1/2 inch difference in the X between the end of the lower stringer and the end of the upper stringer. So what I'll do is I'll just go ahead, it looks like it's a 1/2 inch beyond, and I'll just pull back that component. Instead of saying it's an inch past center line, I'll make it a 1/2 inch past center line. Make sure I adjust both of those components. And now I can be sure that the ends of those stringers will line up, and that just helps with laying out my handrail and make sure they all match. So I already know which settings I want to use for those handrail pieces, so I'm just going to put them in just like I put in the others. So I'm going to start off with my posts, make sure I set those properties, and that'll be using the S76 stanchions component. Start at the bottom, make sure I end at the top. And again, you want to pick which parts this is going to be bearing on. So that'll be my 3 stringer pieces. And then I'm going to make sure that my handrail is set. So I'm going to follow the same properties that I used before with the HSS, the square HSS rails, and then the square pickets. Make sure I apply these settings, and then just apply these to the individual posts. So then I'll go in and add my grab rail. I'll just take the properties of one of the existing grab rails. Then I'll just add some of my finishing touches. Putting my miters on the ends. And then I can add a return like I did at the lower section. So again, I'll open up my polybeam tool. I'll simply go ahead and take the properties from one of the current grab rails. It's very easy for me to go ahead and just throw this in. Come out 3 inches. And obviously you can make these dimensions whatever you like. So I'll come back 3 inches again. If I'd like, I can put a radius on here. You can do any type of finish you'd like on there. And then if you want, you can go ahead and split that so that you know that one section will be shipped with the upper rail and one section will be shipped with the lower rail. Make sure those are welded in place. You always have to remember that Tekla is very shop fabrication and erection driven, so you want to make sure you add welds where welds are required. So now I've laid out an actual floor-to-floor stair section. So I'm pretty much ready to take those pieces and just copy those up the rest of the way. Make sure I go ahead and select these pieces. Since I'm selecting in 2D, I want to make sure I grab all those landing parts. If I look around here, I definitely want to get that return for the grab rail, and I'm also going to grab the connections for where the upper stair is going to be bearing down on this next landing when it gets copied. So I think that should be good. Let's go ahead and copy it up. So I really want to copy this 2 more bays because the 60th floor is really the top floor. 75 feet is going to be my roof. So I'm just going to go ahead and say copy special linear. I'm going to type in 15 feet in the Z. Make sure I set 2 copies and then click copy. So let's see how this looks. So I've got my stair coming up to each floor. So I got my returns. Looks pretty well finished off. So really the only thing I would need to do up here at the top is now to finish off the end of this rail. Again, I could just use a poly beam, or maybe I want to extend this component out a little bit. I could go to the middle rails tab and say that at the top I want to extend 6 inches, and then maybe put a simple railing cap on the end. Again, there's a lot of options you have here as far as what you want it to look like. That's going to depend on the design and what else is in the area. But we give you a lot of options out of the box for how that could be finished off. So if I want to go ahead and put in something like wall rails, I don't need to actually have concrete walls or any type of panels in, but it definitely helps with layout and appearance. So I'm going to go ahead and do that real quick. So just going to rough in a concrete panel. I'm going to leave that 8-inch wide and go ahead and change the height to 840 or 70 feet tall. And I'll just go ahead and make my wall around the perimeter. Now, just for clarity for this model, I'm just going to go ahead and create this on 3 sides. You could, of course, make a 4th side in your own models. And I'll just make sure that's offset right. So now I've got a wall panel, and that's handy for showing up on my drawings, and also just something that I can align my wall rail to. So there's a couple of ways we could do this. Again, I could use something like a poly beam and I could model it in manually. There are other tools that we could use. The one that I'm going to show is a plugin, which is a special kind of component, and this one is called wall rails, and it's meant to do exactly that. So if I were to open up the dialog box, you can see that it's going to show me my insertion points just like a regular component would. I have some dimensions that I can adjust for the height of the rail from the nosing, the length of the rail from the points being picked. So I'm going to go ahead and just make some adjustments here. I get a 2 feet 6 inch tall rail, and the rest of the dimensions I'll just leave the same. Click on the nosing and then come back to the upper nosing of this stair, and it gave me my rail, but I can see that it is towing the wrong direction. So let me just go ahead and change some of those settings. I can adjust the different types of endings. I can adjust how far the return should be at the ends, what type of elbows I want. Do I want to have a poly beam or something like that? And then the different types of brackets and the bracket orientation. So I'll just change the bracket orientation to turn that inwards. I'm going to choose a different type of bracket, one that actually has a wall plate. And something else I could do if I wanted is I could choose a custom component as the type of bracket. So if you have a custom component that you want to use, or you create a custom component for a special bracket that you will need on a regular basis, you can pull it into this wall rail component. So I can either go ahead and reapply this component all the way up, or I can copy it. I'm just going to use the copy command. So I'll copy special. Say I want 15 feet between each stair. I need 3 copies. I'll just redraw the view. Now I can see how I have the wall rail on that far side. And although I don't have a wall here, I'm going to go ahead and create this wall rail anyway, just so I have something that I can make a shop detail of. So it just goes to show that the wall itself is not actually required to make the wall rail. The wall rail is just dependent on the 2 points that I picked to create it, which is your nosing to nosing dimension. Okay, so now I've got a wall roughed in, which is also going to help with my drawings. As I said, I've got my wall rails created. So I think I'm ready to go ahead and make a plan drawing just to show what kind of output you're going to get from this stair on an elevation view. So as you should know about Tekla, all of our drawings are going to be based off of model views. So I'll open up the elevation on the center of the stair, and in that view I'll right click, choose the option to create a general arrangement drawing. We have different settings out of the box. I'm going to use one called elevation. You can see how dimensions were automatically created between all of my grid lines. Any dimensions I need to add, I can add very quickly, because it's going to read directly from that space in the model and pull that here into the drawing. If I want to make a shop drawing out of the handrail or the stair, I can go to our master drawing catalog, and I'm going to use one of the rule sets to automatically create the drawings. And I'm just going to create a drawing of a few samples here. The setting I'm using is going to create each assembly on its own drawing with a bill of material. So now with my drawing list, if I look at one of these stairs, you can see that Tekla creates a drawing with some dimensions automatically. It also has given me a full bill of material. And again, if I need to create dimensions, it's just a matter of picking the points that I want with the dimension tool, and if it's right in the model, it will be right on the drawing. Now we do have some tools available to help dimension this out a little bit faster, with more traditional dimensions that you would see on a stair. I'm going to go ahead and remove some of these dimensions so we can really see clearly what this tool is capable of. So I'm going to go up to my macros, and I'm going to run a macro called zpan stair dimensions. And once I click run, I'm basically going to follow the directions in the lower left of the screen. So first it's asking me to pick the first point of the nosing line and the end of the stringer. And then it's asking me to pick the second point on the nosing line and the end of the stringer. It's already created some dimensions, but now it's going to ask some questions. Do I want to create running dimensions for the nosings? Yes, I do. Do I want to locate a connection part on the left end? Well, since I only have a notch to bear on the supporting steel, I'm going to go ahead and say no. It asks, do I want to locate a connection part on the right end? Again, I'm going to say no. It asks, do I want to add a tread dimension? I'll say yes, and then I'll find an area and pick 2 points to indicate a tread depth. Now you can see it's created my dimensions for the run and the rise. It's also created the nosing point dimensions for all of my treads with an overall dimension combining the tread spacing. So by using this tool, we can very quickly dimension out the stair. Now if I open one of those handrail drawings, by default the handrail drawings will show it flat, like it's being laid out on a shop floor. However, if desired, you can show it upright as it sits in the model by changing the drawing properties. Now upright, it is going to take up more space, so I'm going to quick change this so that it's a 24 by 36 sheet. And then change the view so that it's more upright. You can see that Tekla creates it with very minimal dimensions. I want to show you a very fast way to fully dimension out this rail using an extension that's available in the Tekla warehouse. This extension, called handrail dimensioning, includes a series of buttons that you can click on, and as you see when you hover over the button, it gives you a preview of what the type of dimension is going to be that's going to be created on this sheet. So by simply clicking the buttons that you want, you can very quickly add a series of dimensions for the rails, the grab rail, horizontal and sloping dimensions to whatever your shop standards are. Now these are regular dimensions, so if there was a little bit of extra work you needed to do, or if you needed to edit them at all, you could do so. So hopefully that gives you a good idea of what's possible in Tekla structures for Miscellaneous. The modeling tools that are available allow you to create stair systems very quickly and easily. They're very customizable to the types of handrail that you might do, the different types of stair layouts that you might do, and then the drawings are going to be a direct reflection of the model, including as much information as you want, and even sped up further with the use of some extensions available in the warehouse. Thank you for watching.